This is f of g of x. This g of x is inside the function, right? What is it not? It's not f of x times g of x, because if I needed the derivative of that, I would do product rule. But when I've got one function inside another function, it's a composite function, and this is when we've got to use the chain rule. And you're like, well, what the heck is the chain rule? Okay, well, first of all, before I even tell you what the chain rule is, which of these do you think is one function inside of another? You might say like top row, middle, top row, second row, left side. Well, anyone have an idea? Which of these is a function within a function? I know we're just starting this, so if you get it wrong, that's okay. Bottom row, middle. Yeah, this is saying we've got the sign of x squared plus 4. So you guys, how I describe this sign is the outer function, i.e. the candy shell. This x squared plus 4 is the inner chocolate. Anyone have another one that they think? Bottom right, absolutely. We've got an outer cosine, inner angle, okay? Middle right. This one? Yeah. Yeah, buddy. How could I write that with an exponent instead? 25 minus x squared to the... Yeah. And so, Elliot, this 1/2 is my outer shell, if you will. And then this 25 minus x squared is my inner chocolate. Okay. Middle. Mr. Gavin, you said middle. Agreed, Gav. This 2/3 is my outer shell. This x squared minus 2x minus 1, that's my inner chocolate. Middle left. 3x to the half. We got an outer shell and an inner chocolate. Agreed. Yeah, you guys are getting it. Yeah, why didn't I switch those up a little bit? Yeah, it's just these bottom 2 rows. Do you agree this is some function to a power plus another function? There's no outer and inner here. This one could be a little confusing, but isn't this something times sine of x? So this would be product rule. What about this one? Quotient rule. Yep, do we just have division? Sound good? So these bottom ones are all composite functions, something within something else. So to find the derivative of a composite function, do you think you can make sense of this crazy formula? And we'll put it in words. What the heck? Here's what I want you to think of. Ready? What could I describe? Right here. F versus G. Which one is outer? Which one is inner? F is outer. I agree. F is outer. G is inner. Elliot, you want to be my guinea pig? See if you can fill in these blanks based on this. Ready? What do you think we did to that outer?
You took the derivative.
Perfect. That's what I'm going to say right here. Derivative of the outer. Then Elliot, he said, all right, derivative of my outer, f, was f prime. What did they do to the inner, buddy? It was g of x. It stayed g of x.
No, they didn't do anything.
Great. So how I worded that is just leave the inner.
Times the derivative of the inner.
Oh, snap. Look at what they said. Times g prime, and he said times the derivative of the inner. Buddy, you are on it. Times the derivative of the inner. Whew. Think of. All right. Down here, do you agree 4 is my outer? X cubed plus 5x is my inner. When I say take the derivative of the outer, that's what Mr. Elliot just said right here. F has to be f prime. How would I take, and you don't need to write this down, you guys, but how would I take the derivative, say, like x to the 4th? You agree it's 4x to the 3rd. So to take the derivative of this thing, it says take the derivative of the outer, it's going to be 4 something to the 3rd, and that something is just going to be that inner. That inner stays. So Elliot said take the derivative of the outer, so I'm going to say 4, come on, little Apple Pencil, 4 something to the 3rd. That right there is the derivative of the outer. And he said leave the inner. So I'm going to leave that as an x cubed plus 5x. Then you're going to times by the derivative of the inner. What's the derivative of my inner, Steffi?
3x squared plus 5.
Perfect. Notice that I put that in parentheses because it has to be multiplied by all of that. Steph, we're done. Okay. Who can help me out with 2? I would first rewrite it as something to an outer. Yeah, Cam. This is the same as h of x to the 1/3. Have I done any calculus yet? No. She just rewrote it to have an outer and an inner. Okay, who's got me? What's the derivative? Oh, Cam. What's the derivative of my outer? 1/3, leave the inner. H of x. That exponent becomes beautiful. So you guys, she just took the derivative of the outer. She brought her 1/3 out front and took her exponent down by 1 and left the inner. Campbell, perfect. Then Cam, it says take the derivative of the outer, leave the inner. Now we got to multiply by the derivative of the inner. If my inner is h, what are you going to call the derivative of the inner? H prime of x. Done. Guys, I keep spitting on myself. This is embarrassing. And who's got me? My function is p of x, is j of h of x. There's no multiplying here. J of h of x. Gav, you want to try it? Sure. Okay, sure. J is what versus h of x is what versus outers and inners, buddy? J is the outer. I agree. J is on the outside, h of x. Cool. So, bud, first we always do the derivative with respect to x. Don't be plugging in that 1 yet. Oh, you feel me, Gav? Yeah. Okay. Gav, derivative of the outer would be. My outer is j. So the derivative of it would be j prime. You just took the derivative of the outer. Then, don't get your little dot for your j and your prime mixed up, people. That's confusing. Then, Gavin, we got to leave the inner. What are we going to say? J prime of what? Of h of x. They're not being multiplied. It's of. Great. And then, Gabby, look, it says times the derivative of the inner. What's the derivative of h? H prime, buddy, of x. Perfect. Guys, we're going to go replace every x with a 1. P prime of 1 is j prime of h of 1 times h prime of 1. I realize writing all of that a lot is annoying, but this stuff is hard. We got to write it out. I'm going to do some highlighting. This j, this dotted line is a graph of j. And then this blue, wow, that is not blue. This green line is my h info. So how the heck am I going to analyze this? What do you think I need to find first? H of 1. Let's go find h of 1. Is h of 1 a point or a slope? H of 1 is equal to point. H of 1, h is my green graph. Did your graph come out okay? Not really. No, not really at all. I'm sorry. H of 1, look at my graph. H of 1, green.
Oh, wait, sorry.
You don't have to apologize. This came out terribly. So, 3? Here's what I want us to think of. P prime of 1. Do you agree we have not used this j prime yet? I'm leaving my j prime alone because you said we had to find h of 1 first and you were right. And we said h of 1 was 3. That is a point. And then, Gavin Miller, time for you. H prime of 1 is the slope of this green line. Again, you probably can't see on your graph, so maybe you do a little something like this. Down 3 over 1. So maybe you do something like that to let yourself know what that h prime was. G, you were right. -3. Question, do I multiply 3 times -3 here? No, I do not. We got to find j prime of 3, right? J prime of 3 is, I got to go to my graph of j. Am I looking at a point or a slope? Prime. Slope. My j graph is red. When x is 3 is here. Could be the slope of this line at any point. What do you think? Yeah, -1, 3. Down 1 over 3. So now we got -1/3 times -3. Negative times a negative? 1/3 of 3 is 1. And that's, here we go. If h is cosine of f of x, cosine versus f of x, one's my outer, one's my inner. Which one's cosine? Gamby, what do you think? Cosine, outer or inner? Probably the outer. I think that's a great guess. And f of x is my inner. Gamby, if they say find h prime of 1, let's start with h prime of x. What's the derivative of my outer? You remember derivative cosine, Gambone? Close. Negative sign. Gamby, leave my inner. What's my inner? Yep, and then it's times the derivative of my inner. Gambone, how would I say it's times the derivative of f? What's the derivative of f? How would I say that? F. Thanks. Good job, Drew. Thanks for helping. Okay, Gambone, I'm not letting you off the hook. We got to replace every x with a 1. We got h prime of 1 equals negative sign of f of 1. So many parentheses. Times f prime of 1. What do we need to do first? Let's go find f of 1. Gambone, from my table, can you find f of 1 for me?
Pi over 6.
You got it. So I'm going to rewrite that we've got negative sign of pi over 6. Then, Gamby, I need f prime of 1 from my table.
4 root 3.
You got it. 4 root 3. Ooh! Unit, circle, clap, 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 clap. Pi over 6. Lucal. The point there at pi over 6, because it's the first one, is root 3 over 2, 1/2. So the sign there is 1/2, and then you're saying just throw a negative in front of it? Beautiful. You were right, Elliot. Negative 1/2. I'm just trying to share the love. Times 4 root 3. Lucal, what is half of 4? My answer is going to be negative 2 root 3. Okay, if I were you, I would end right here because this no longer has variables. Are we going to mess up the unit circle? Probably. You could have ended right here. What?
With the
Yes.
sign?
Yeah. Yep, because that's not a variable. This is a function. Pi is a constant. But if this would be multiple choice for them, this would be their answer. Yeah. Gavin's so mad. We took the derivative of the outer. Derivative of E is always E. We left the inner times the derivative of the inner. Now, I understand, Gav, when I told you like cosine, or if we had like, okay, you guys. Now they want j prime of 2. I'm going to replace every x with the 2. So I've got e to the g of 2 times g prime of 2. G of 2 is 8. So we've got j prime of 2 is 8 times, what's g prime of 2? 5. Oh, wait, I forgot my e, didn't I? Oh, golly, you guys, this looks disgusting.
Would be E of
E to the 8th times 5, right? Whew. So it'd be 5 e to the 8th. All right, let's keep practicing. E to the 3x. Derivative of e is e to the 3x times the derivative of the inner. 3. Could we just say 3e to the 3x?
Yeah.
Yes.
Is that it?
That's it. Oh!
That was loud.
4, a Milky Way. Which one is my outer? It is ln. Therefore, this is my inner. Who can remember the derivative of ln, G?
1 over x.
Okay, in this case, it'd be 1 over, leave the inner, right? Okay, so he says, all right, 1 over, leave that inner. Because let's refresh real fast, G. When I said, hey, what's the derivative ln of x? You agree it's 1 over x because that was what was my inner.
Oh, but it's the ln of that.
You feel me? Yeah, you got it. Okay. Ooh, G, psh, psh, times the derivative of my inner.
5.
Yes, sir. Steffi says, can I write that as 5 over 5x plus 1? Steph, AP would have their answer like that. Could someone go like this? No. No. There is addition between there. No. What if my answer was this, though? Then could they say 1 over x plus 1? By going psh, 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 exactly. Okay, help me out, people. Derivative of e to the sine of x minus 3. Okay, abs. E to the sine of x minus 3x. Agreed. You took the derivative of my outer. You left the inner, abs. Now we need to multiply by the derivative of the inner. Derivative of sine. Yes, ma'am. Derivative of minus 3x. Perfect. Who's got me? Who's got me? Lucal. What? Careful. What's the derivative of my outer? ln. 1 over, leave my inner. You got this, bud. So it's going to be 1 over what? Very good. Times the derivative of that inner. Beautiful. Lucal, is that the same as cosine over sine? Lucal, is that the same as cotangent? Whoo!
Secant, tangent.
The derivative of secant of 2x, which is my outer. Secant. Okay. Which is my inner.
2x.
Okay. Just a reminder. To find the derivative of this, because it's a chain rule, it's got an outer and inner. You have to take the derivative of the outer and leave the inner. Does anyone have any idea what that might look like? Cam? Yeah. Okay, you guys. Do you guys agree the derivative of secant is secant tangent? But look, this x stayed there and stayed there. So isn't this 2x, as Campbell said, going to stay with my derivative? Yeah. So the derivative of secant is secant of the angle, tangent of the angle. Cam, so good. What do we need to multiply that by? How'd you get that? The derivative of the inner. Perfectly said, Cam. Cam, what you having? Question. Is that the same as secant of 4x, tangent of 4x? Or is it the secant, the equivalent to 2 secant 2x, tangent 2x? Or both? That's my mad face. That's this face. Yeah, like Campbell said, you cannot mess with the angles ever. Yeah, no. This constant can come out front though.